Hello everybody and welcome back to the next lecture in the Metasploit framework or system hacking section. So let us actually take a better look actually at the structure of the Metasploit framework itself. So in order to do that, let us first exit the command tool. Let me clear the screen. And the first thing you want to know is where are all the modules, encoders, payloads, exploits actually stored. So they are stored in the user. Let me just cd user share, and then you go to the Metasploit framework. Once you change the directory to that, you can just type here ls and you will see a bunch of these files, and I will show you what are the more important ones and the ones that we will use. Now let's see first of all. So the first one is the MSF console. Let me just find it, which is right here. We used it in the previous video. It is used as a program to run the console itself and actually perform the attacks. Now, one of the also important ones is the MSF Venom. Now, this program we will use in order to create our payloads, our interpreter shells and backdoors. So we do that with this command like right here, and also you can update your Metasploit framework with the MSF update command. Most of the others are not so important at the moment. Now if you want, it's good to know that the Metasploit framework and all of the exploits are written in Ruby, which is a programming language similar to Python. So if you know that language, it is also a plus. Now in order for you to find all of the exploits and payloads, you need to go to the modules directory. Everything is stored in there. So if you go into the modules and click ls right here, you will see that we have all of the things that I talked about before. So we have auxiliary, encoders, evasion, exploits, NOPs, payloads, posts. Now let's explain all of those in detail. So exploits, as we said before, they're basically used to target a vulnerable software running on a remote machine. So let's actually change our directory to exploits and cd exploits and type here ls. You will notice that you have a different exploits for different types of operating systems and different types of platforms. So for example, you have Linux, Windows, Unix, Solaris, Android, Apple exploits, so also browser exploits, as we see Firefox. There are a bunch of these separated directories for different types of exploits. So let's actually try to find the exploit that I talked about in the previous video, the one for the Windows 7 and Windows 8 machine, I believe, which is the Eternal Blue exploit from 2017. It is a Windows exploit. So we go to the Windows and we type here ls. There is a future division between all of these exploits, as we can see right here. Some of them are mostly divided by the port number or the service that they are running on a certain port. For example, we can see HTTP, it is running on port 80. We can see SSH port 22, FTP port 21. We can see SMB port 445, I believe, or something like that. So let us go to the SMB, since there is the Eternal Blue exploit. If you type here ls, you will see a bunch of these different exploits used for the SMB. Now here it is, the Eternal Blue Windows 8.py exploit. We also have the regular Eternal Blue exploit, and all of these are .rp, which basically stands that they are Ruby files and the Ruby exploits, or exploits just written in Ruby, as I said before. So if you wanted to, you could actually nano some of them in order to see how they look like. So MS17, let's see how does Eternal Blue look like. So .rb, and we can see the code of the exploit itself. So it is written in Ruby, as I said. You can check out a bunch of these things right here. Now I do not know Ruby, so I will not be actually explaining what all of this does. It is similar to Python. You can actually understand it if you did learn some of the programming languages before. But for now on, I just wanted to show you the simple code behind this exploit. So let's close this and let's actually go back to the modules. So we change our directory back to the modules, and let's talk about, for example, the payload section. So for the payloads directory, let's change first of all the directory to payloads and type here ls in order to see what we have. And here we have different types of payloads. As I said before, those are files that we send to victim, for example backdoors. Now, as we can see, there are three types right here: singles, stagers, and stages. Now, singles are basically used to, they are smaller payloads, and they're used to actually perform only one action. Stagers right here, they can be used to deliver another payloads, and the stages are some of the larger exploits, or not exploits, some of the larger payloads, pardon me. For example, the interpreter shell that we will use in most of our attacks. Now, what is a interpreter shell? That is basically a shell with a bunch of different options that we can use after we exploit the remote system. So we can actually screenshot the desktop, we can run a keylogger, we can bypass antiviruses, we can do a bunch of these stuffs with the Meterpreter reverse shell. So it gives us a bunch of options to use. We can upload other payloads as well with Meterpreter, we can download files, upload files, and some of the other things that we will cover in the next tutorials. So that would be about it for the payload. Let us check what else we have. So we have auxiliary, so let's go to the auxiliary modules and just type here ls. And you will see that they are divided also in different types. So we have fuzzers, spoofers, sniffers, different type of auxiliary modules. But most likely auxiliary will only be scanners that you perform on a target. So for example, you can scan if a target is vulnerable to some type of the attack, and sometimes auxiliary modules are also used to brute force, for example SSH, Tomcat, and other different stuff that we will also cover in the next video. So that will be about it for the auxiliary. You can check out all of these other subdirectories if you want to and see what does it have in them. For example, let's go to fuzzers. You will have in the SSH also some of the some of the auxiliary modules written in Ruby language. So that will be about it for the auxiliary. Now let's talk about the encoders. So if I type here ls, you will have the encoders. Let's go to that directory, type here ls once again, and these are the encoders for different types of machines. So encoders are mostly used to bypass antiviruses. Now you can change how the code looks with the encoder, or you can scramble the code and then the antivirus database can't recognize it actually. Now how the antivirus databases work, or basically how does most of the antivirus work, is they have a huge database where they have all of the known exploits, all of the known viruses, trojans, and malware basically that they have in their database. And once you run some of the program on your PC, which is a malware, and it is also known to that database, your antivirus will prevent it from running and it will delete it. But if you, for example, change the code a little bit and scramble the code, or even better, write the malware yourself, then most likely most of the antivirus won't be able to detect it, since it is firstly time that they see a code like that, and that code is not in their database, so therefore they cannot really detect that code. And they let it as a normal program and not as a malware. That's why coding your own malware is a big advantage. So that would be about it for the encoders. We will also show how to use them later on, but for now on, let's just explain all of this. So the post right here is basically some of the tools or programs that you will use after you exploit the target. For example, you send Meterpreter, which is a reverse shell that we will use. You can upload from the Meterpreter other post-exploitation programs that you can use to gather, for example, passwords gathering, or basically any other information gathering you want. You can gather, for example, cookies if you want to from the certain browser. The thing that you might not really know what it is, which is NOPs. Well, basically, if you ever encountered in assembly code, or if you're an assembly programmer as well, you will most likely know what NOP is. It is short for no operation. It is basically a command in the assembly language that just performs no operation. Now, this is most popular known for on x86 chips as 0x90 bytes. So this is the byte for a NOP instruction. When a processor loads this instruction, it simply doesn't do anything. It basically just skips those instructions until it comes to the next useful instruction. It just does nothing for one cycle and then advances the register to the next instruction. Now, why are these NOPs useful? Well, basically, the NOPs keep the payload size consistent. The practical importance of this has to do with writing instruction jumps. Now, if you do not know what instruction jumps, it doesn't really matter that much, but jumps can either be relative or absolute jumps. For basically, if you move data around at all with an absolute jump, you must recode any references to it. If you move one instruction around relative to another, you must also recode the relative jump. Putting NOPs basically simplifies the problem, because a jump that lands anywhere in a series of NOPs will continue on the first executable instruction and prevent the processor from reading an invalid code that could stop execution and crash the software. So basically, from all of this, you just need to remember that NOPs is an instruction which is referred to as a byte 0 or as a byte 90, and basically it doesn't do anything. So that's what you need to know. We will probably use it later on in some other section, but for now on, this would be enough for you to understand the basic structure of the Metasploit framework. And in the next lectures, we will actually start covering some of these scanners and exploits that we can use on our vulnerable targets. So that would be it for this tutorial, and I hope I see you in the next one. Bye.